Okay, welcome guys. Let's continue where we left off. I figured out what error was causing the segmentation fault thing. Yeah, if you go back to the node, I created the head node, right? But I didn't give it an address. You see, I didn't say head is equals to a new node. I forgot to do that. And that so every time I try to do this, setting the heads next to that, I'm basically trying to okay, this way was fine because I'm just updating that the next node. But then whenever you try doing something like this, you're trying to point to an address that doesn't exist. The head has no address. So yeah, it eventually ends up giving you an error. It might skip and ignore, but eventually it's going to give you an error. So let me just output the node, right? So remember we started the it's next or the first element. Then you just say while it's true. And then we're just gonna output the node. So let me see. Yeah, let's just output the node. So current value by space. And then we move on to the next node. Current is equal to current next address. Then we move on to the next node. Simple as that. And then if my current address happens to be equal to nodes next, which is the address of the first node, then I must break the loop. Because remember, it's just while true. So I need to break the loop at some point, or else it's going to end up being an infinite loop. So I'm just going to build it again and then execute. There we go. So A, B, C, D, E. It did add it to the end. But then I must also put in an end of line character at the end there. There we go. Then there we go, A, B, C, D, E. It did add. So now it's working perfectly fine. Yeah, I remember now. I know why the error was there. Such a small issue. I didn't give the head. I didn't allocate memory for the head. Basically, I was supposed to say give memory for the head, enough memory to store a node that stores character. And what is the node? It's this type, which takes in the value and an address of the next node. So I just forgot to add that line there, and it affected everything. So now I can. Okay, I don't want to make it. Yeah, I don't want to make it a bit problematic. Add more things. So I'm just gonna leave it like this. I won't add any more things here. So that's everything. That's question 2.6. So this was fine. I was 100% sure this is fine. Just that there was that small error. So now this is how you would traverse or go through a linked list that is secular. So basically secular means that the last element or the last node points back to the first node. This is how you would go through it. And we could output it the right way. We could do that if statement to use arrows. We could do that, but I don't want to make it more complicated. I just want to make it simple, like this. Just put a space after each node when you're displaying it. As simple as that. So we are done with this one, with this question. We're totally done with it. So now we need to answer this question. So describe how a queue can be implemented using a linked list. So remember, a queue is first in, first out. Yeah, it's FIFO. If you know a queue, for example, you're at the queue at the bank. That's the queue they're talking about. So it's literally the same thing. Yeah, they're talking about the same queue that you're used to. So you can imagine this is you in a queue. Oh, come on. Mm, there we go. Okay, I feel like it's not big enough, maybe. Maybe that's why. Okay, so you can imagine this is you in a queue. Right, and then I'm gonna give him arms. There he goes. He has arms. Then I'm gonna give him legs. And then there's the other leg. There we go. So this is right. So I'm gonna have, and this is another person in the queue. There's another person in the queue. Then there's a last person in the queue. So all of you are in a queue, right? This is a queue where each element is, so you have the first person, number one. Okay, I'm just gonna put the labels at the top. And then number two, number three, number four, right? So 2, 3, 4, right? So this is people in a queue, right? So you see it's in increasing order. 1, 2, 3, 4. 1 meaning that this is the first person to be in the queue. This is the second person. This is the third person. This is the fourth person. So this is the queue, right? So basically, it's first come, first serve. That's what it means. It's first come, first serve. So it's we typically use the term FIFO to refer to it. So FIFO meaning first in, first out. So first in, first out, it means that the first person to come in is the first person to go in or to come out of the queue. First out, first out. The first person to come in the queue is the first person to go out of the queue. First in, first out. Let me. Okay, let me just create the main bits. Downloads. Okay, let me not call it main P. Let me just call it part 6, right? I think it's part 6. I should have labeled them in terms of what part, what video part is it. So the question is, how would you implement using a linked list? So remember linked list, right? You can imagine that each person, right, is it represents a node. And then each person is going to have the address of the next person, right? So if I wanted to implement a node, right, to implement a list using a node, what I can do is I can remove from the front. So remove the first element. So if I insert a node, if you check the way we're inserting nodes, right? So how would we implement it using a linked list? So let's check that out. And then return 0, right? So let's do it. Let's do this thing. Let's check it out. So remember, I'm going to have a template, type name T, and then struct node So the node and then T some value, and then the node type T, next node's address. So I'm going to use a pointer because pointers store addresses. So we have our node, it's ready, right? So I'm going to need to create a node, let's say a node of characters, just like we had previously. I'm going to have a head and a. Those are going to be my pointers, right? And I'm going to set the head to point to a new node that I'm going to create on the heap. Then A is going to be new node again that's going to create on the heap, right? So they both have addresses now. They both have addresses. Now, what I'm going to do is let's just imagine it's a okay. It's any okay. The question is here: how would you implement using a linked list? The question is how can you mimic a queue using a linked list? Because remember, I have the first node which points to the last node, which points to the next node, and then the other node, the next node points to the node after it. So they all point to the next person. So it's like this. All point to the next person. So it's like this. And then this last person points to nothing. As you can see, there's nothing that this next person is pointing to. So we know this is the last person in our linked list. So if this is the case, right, the way we can implement it, right, we can remove nodes from the front. The thing is, I want the right terminology for us to use here so that we indeed answer the question the way they want it to be answered. And then remember the first element is going to store it's going to be, we're going to store it inside a node called head so that we keep track of the head. So it's going to be stored in the node pointer called head so that we know we are referring to the first element, right? So it's going to be like this. So how would we mimic a queue? So the way we mimic a queue, would insert it the normal way of inserting it because the nodes, remember you insert after, right? And then now when you're removing from the queue, from the linked list, remember queue you remove from the front or you basically move from the front and then you shift everything. But then with the linked list is very easy to shift because the way you can do it is the first thing that you need to do, right? So that you don't lose this point. If you want to remove from this node, you can do this. You can take this, paste, and then move it here, make this one point to this, and then do this, and then change this one to point to nothing. And then now this one is no longer part of the linked list. So in simple terms, that's how you can mimic a queue using a linked list. But the question is, what terms do they want you to use in order to explain, in order to answer this question? So let me just check the slides if there is some helpful information on this. But they did put on the slides, just that I need to see how they phrase it. But yeah, I can just remove from the front of the linked list and change pointers and stuff, yeah. But then I don't want this, I want queues, right? Yeah, it's a lot of slides. 108 pages, that's a lot. Or linked list implementation. Linked list can dynamically organize data in a linked representation. Stack top is a pointer to the. Okay, I feel like you just need to explain. I'm just seeing the stack here. I think you just need to explain the same way I was trying to explain it. Like basically, I feel like they sort of like want the algorithm of how can you achieve that. Okay, queues. As I said, first in, first out, FIFO or FIFO, however you want to pronounce it, but it's pronounced as FIFO. So FIFO, first out, first in, first out. So the first person to come in is the first person to go out. It's a queue. So you add to the end, to the back or the rear, and you delete from the other end, which is the front. So that's a queue. So implementation as arrays, right? We don't want to see as arrays. How would you implement it? You see, as arrays becomes very, it's gonna become very. I feel like in a way it's very complicated to implement with the array because you have to shift every element to its previous location, to the previous location. So for example, if I'm removing at index 0, I must shift every value from index 1 to index 0, shift value from index 2 to index 1. I keep shifting until, imagine you have 99 elements. That's going to be a lot of work. With the linked list, it's going to be very fast. So let's check as to implement them as linked list. But I feel like the way I explained it is how they want you to explain it, but with a bit of more English in there. Summary. Wait, that's the end. Where's the linked? Yeah, a linked implementation. Yeah. Yeah, this is what they want. So array implementation has issues. Array size is fixed, so you can only store a finite number of queue elements, and then requires array to be treated in a special way. So you have to treat the array in a very special way. And then linked implementation of the queue simplifies many issues, which is very good. It does simplify. Queue is never full because the memory is allocated dynamically. Yeah, it's never full. You keep adding. If you remember in our previous tutorial, you just keep adding. If you want to add another person, just add another person. It's never going to be full. That's the beauty of linked list. So linked list implementation, empty and full. Yeah, I feel like they want these points here. So you can just say elements are added at one end and removed from the other. So you need only 2 pointers to maintain the queue front and the queue rear. Okay, so remember what I said. You're gonna need pointers, right? Remember when I was talking about the tail. So we also had the tail, right? So this is question, or is it 1 or 2? It's 1.9. Okay, so question 1.9. There we go. So I'm gonna also need a tail. So I need to keep track of the beginning and the end. So tail is equals to new node. I need to give it an address. I must not forget to initialize all of them like this. That's something I shouldn't forget. And then, yeah, we can, okay, for node A, right? We can just make it point to null point at the moment. Oh, okay, no, for the tail. Okay, I see tail. Yeah, tail, you have to, for the tail, you have to say, let me think. I think for the tail, you have to just set it to null pointer. Yeah, you set it to null point, the tail, because remember the tail just represents, no, it's not it's not the tail. It's a null pointer. Yeah, I'm not mixing it up. So you see what null pointer does, right? Remember, this is going to point now. what the tail does, right? You're gonna have a null value here. So we're gonna have some diagram here, right? Yeah, which represents null, right? So what the tail does, the tail points to the last node. Basically the node that's pointing to null pointer. That's what it points to. And then I'm gonna insert text. So this is going to be my tail. It points to the node that's pointing to null pointer. That's basically the last node. So that's how you're gonna explain it. You're gonna say you can create. This is how you're gonna answer it. You can say I'm just gonna say this is the answer, right? Create two pointers, head and tail. Head points. The head points to the first node, and tail points to the last node. And then to insert, you can just also explain more. I don't know how they want you to explain it, but this is in simple terms how to explain it. You can just say, for example, to insert, you insert a new node at the rear end, then update the tail point to the new node, right? Then yeah, just in simple terms, you don't have to go in more details. And then to remove, you change the heads next to point to the next node. Then the first node's next points to null pointer. Or you remove it from the queue. So what do I mean by this? So remember what he said, right? So you have this, you have these nodes, right? Let's just say, for example, at the beginning we have this. We have this nodes, right? And then we have text. Let me click here so that I can insert text there. Null pointer, right? So that's null pointer, points to nothing. That's nothing, basically. So I'm gonna have this linked list, right? So to insert, or to let's just say to insert, how would you insert? So you'd insert the node at the end, which is here. That's what I meant. And then you update the tails next, or the tails at address point to the new node. That's all you have to do. You see how simple that is. And then when it comes to deleting a new node, removing a node from the front, you have to say you remove it from, to remove, you remove from the front. Yeah, to remove, you remove from the front. You also need to state that. So you remove from the front, from here, the first node. So how do you do that? You explain, you say, you tell them that you update the heads next to point to the next element. And then you update this pointer to now point to null. It's a different null. It's not this null. Okay, it's fine. You can point to this now, but yeah, you see, now it's pointing here to this now. And since it's now pointing to this now, it's no longer part of this linked list. It's now on its own. You see, it's standalone. So now it disappears. We have removed that node. Yes. It's now pointing to null. It's not pointing to this one anymore. So there's no link anymore. So that's how simple it is to implement a queue using a linked list. Okay, so yeah, this is how you would implement it. So yeah, that's pretty much it. Now the question is, how do we do the DLLs? So let's check the slides. I'm not really quite familiar with DLLs, but we'll just have a look and see how it is. Okay, it's under exception handling notes. Okay, there it is. I don't think it's there in the textbook though. Okay, I just want to, I also need to remove this textbook because I'm no longer using it. Okay, it's gonna have the page numbers, right? Okay, no, it's talking about the computers and stuff, so I don't want that information. Okay, it doesn't have yeah, this circular linked list. You can also check it from the slide, from the textbook. There's also doubly linked list, then the singly linked list. Okay, they don't have DLLs on this textbook. So we're just gonna have to depend on the slides. So with the slides, I guess for DLLs, you just have to look at the slides. Try to remember the formula for the DLLs, but we're just gonna do it and see. Okay, I think it's lecture 5 then. Yeah, I think it's this one. Okay, so let's look at DLLs in more detail. So DLLs are a mechanism for loading functionality at runtime under Windows. So what does it mean to load functionality at runtime? So basically it's to load things when the program is running. You don't load it when it's compiling. Compiling basically it's checking if it's compiling. Remember, compiling, what it does, it's converting your code, because remember, this is doesn't know what node, what all these things are. The computer doesn't speak this language. It speaks zeros and ones. So compiler has to translate this into a into machine language or machine code, basically zeros and ones. So with those zeros and ones, the object file, you don't necessarily have zeros and ones. You would have, it's going to have like characters, string of characters to represent each binary number. So DLLs are a mechanism for loading functionality at runtime under Windows. Unix systems have DSOs, dynamically shared objects. So there are a variety of different kinds of DLLs. We have Win32 DLLs, and we have component model DLLs. Then there's ActiveX DLLs. Functions are exported from a DLL by ordinal number and optionally also by name. So you can export the functions, right, by using some number called an ordinal number, or you can export it by its function name. So DLLs are loaded into the same address space as the application, and therefore pointer-based data may be passed to export functions. So basically what they're saying is that wherever your application is stored in memory, the DLLs are also loaded in that same memory, that same memory location. It might have a different address, but it's inside the same memory location. So it's like, for example, we are in Auckland Park, right? Someone stays in Brixton, someone stays in Western, but we are around the same address space. It's still the same related address space. It's Auckland Park. I would say, yeah, in that way, it makes much more sense to say Auckland Park, even though it's like different places, like Westin is its own place, Brixton is its own place. Or you can just say, for example, you and your friend both stay in Westin, which is the same address space, but you have different addresses. The house that you stay in is a different address from your friend's address, but then you all both stay in the same address space, which is Westin or Brixton, whatever situation may be. So that's what they're saying here. They're saying that the DLOs are loaded into wherever you are staying. If you're staying in Brixton, the DLOs are also loaded in Brixton in a different address though, because everything needs to have its own unique address. So DLLs are written in one language, can often be used in another. So the flexibility with DLL is that you can write it in, for example, Python, a different language, but then use it in C++. That's that's the beauty of DLLs. So let's let's create the header file. So I feel like you just have to know all of this. See all of this code here. You have no choice but to know all of it if you want to get those 20 marks. And then okay, so we're gonna have to need to add mesh w's dev c++ bin direct to your path or directly work from there. Okay, so since I don't have Windows operating system, I can't compile it in this way. So I'm just gonna write the code, but you guys have to test it on your side. Yeah, this is a lot of information. So let's just do the DLL. So we're just gonna check the header file and become familiar with the header file and see what's going on there. So let me reduce this to balanced. Okay, so let's define the header file, right? So I'm no longer going to use this anymore, Visual Studio Code. I'm just going to use code blocks so that I don't want to have to type everything. So I'm just going to use code blocks so to create the header files and the CPP file. So console application, I'm going to call it DLL. Okay, let me go back and use a capital letters DLL. And then we have our code. Why does it have, oh, I have to, it is, every time I close, I must update that file so that it saves these changes. I'll update it later. So let me view this perspective to minimal so that it can be like this. Yeah, there we go. And then I create a new file, a header file. CPP header file, skip this next time. So I'm gonna call it DLL, capital letters. And then save it where my project is. I don't want the underscore included. And then I say all. And then I'm gonna create, okay, I think we just need the header file. We won't need more than that. Just gonna need a header file and a main.cpp. So let's look at the slides. So if defined building, so it defines where the DLL symbols will be exported. So you have to, it basically defines whether this function that you're creating will be exported to wherever you're exporting it to. Remember, the DLL, it's a way to execute functions at runtime, to export functions at runtime. So let's do that. So I'm gonna say, I don't know what they want you to call it. So let's see. DLL municipality function. The DLL contains the following function exported without C++ name mangling. So we're gonna check that. Yeah, so yeah, we need to use extend C to turn off the name mangling. Let's see. I think we can call it any name. Oh, we can use, oh, I see now. They're using the name, the header file's name to define it. Okay, so we're just gonna use whatever a header file you've called it. That's the one you're gonna use to name it. So I'm just gonna say if it's defined, what is defined? This building, this DLL, if it is defined, then it will be exported. And then if it is defined, then it's going to export it. Then you define it here for export or for import. You can define it so that it can be exported, or you can define it so that it can be imported. So they can do two things. They can import it and you can also export it. You can send it. Remember, export is just to send. To import is just to retrieve or to get it. So if I don't know if this building underscore example DLL is how you should create it, should add it there or what? Let me see. Yeah, they didn't explain. These slides, they don't really explain. No wonder the knowledge that I have about DLLs is a bit shaky. So let's just do it the way they did it in the slides. So if defined, right? And then you put building before it. So if defined, then you're gonna be building. I'm assuming you're gonna be building the DLL. And then define it. Gonna be called DLL underscore H underscore declare. Declare what? Declare spec. Declare, okay, 2 underscores. So declare spec, let's see. Declare 2 underscores like this, and then declare spec, right? And then DLL export. The DLL export or exported via export. And then else we define the DLL to be able to import it, declare spec, and then DLL import this. Okay, everything seems fine. And then we disable name mangling. So what this, I think I remember, if I remember a bit, I think what extend C does, we're exporting it as a C function, if I'm not mistaken. So calling conventions refer to the way in which we use registers, and stack are used to pass arguments to functions. Standard call is the name convention of the Win32 API. Oh, okay. So since we are using a Windows, we're gonna use the standard call. That's the convention. That's how you call it. It's a standard call. STD stands for standard. Standard call is the naming convention on a Windows 32-bit API. If you're creating a Windows 32 API, okay, okay. So we're gonna create extend C. I think it is extend C, or is to export it as a C function, if I'm not mistaken. And then the question is, I don't know about this first one. See, with this first one, I'm not sure about that function, but I think the one that we want to export is the second one. The thing is, this slides, they don't explain. I don't understand why they do that. Let me see. Power. Okay. I think, let me see. I think we only have to declare one function here, because this one, I feel like it's a different function on its own. It's just for greeting. It's a C function for greeting. And here they use standard core, but then on this one, they didn't use standard core. Don't know why that is, because it didn't explain here. They didn't go in depth of what's going on here. So just declare one function here, the function that you want to export. And then remember, you've created a DLL code of that header file that you've created. So you need to say the return type of the function followed by that name of the DLL so that it gets exported with the DLL. So let's do that. So with this function, they said they must do what? Okay, this is the function that we need to import. Am I answering the question? Okay, so yeah, we must write code for the header file. So if you can remember the header file, you are good to go. And then remember, I've created this header file using the DLL using the name of the header file. So I must put that name of the header file after the return type. The name of the DLL, I mean. Okay, yeah, this should be fine. So like this. There we go. I think this should be fine. That's enough information that you need to have there. And then write code for a batch file that can implicitly link the DLL, assuming the existence of a main.cpp. Now you have to run those commands, what G++, whatever commands you have to run in order to build the okay, write code for the main. Okay, yeah. So if you can know the code for the header file and the main, you definitely gonna get. They always ask those questions. You're gonna get, I'd say, more than 50% for the question. So how do you know the header file and the main.cpp? The header file, you're just gonna always define it like this. So always make sure that you put building before the name of the header file to say that you're building this, you're building a DLL. You can just say you're building a DLL. And then you define the name of the DLL, DLL underscore H, which is just the name of the header file. And then you declare so that it can be exported. And then you declare it again so that it can be imported. Then you just remove, turn off name mangling, and then you declare the function within the function that you're supposed to export within the extend C. And once you're done declaring it, make sure that you put the name of the DLL that you've defined here after the return type. So if I'm returning a double, after the double return type, I put that name there that I've declared. So that's all you need to know for now. Don't have to worry about all of these things. As for the batch file, you might know it, you might not remember it, but let's just check it out. Because I think that's all you have to write here. So calling conventions refer. Okay, I think you might also have to put standard call. Let's try to understand what standard call is. Calling conventions refer to the way in which you use registers and the stack. Refer to the way in which we use registers and the stack are used to pass arguments to functions. Standard call is the calling convention of the Win32 API. So if you're dealing with the Win32 API and you want to do standard call, that's where you'd put the standard call there. But then other than that, I don't see where they did specify in the question that, okay, you should do a calling convention of the Win32 API, you should do a standard call. I didn't see it anywhere, but just to be safe, you can just put it there. You can just say underscore standard call the Win32 API. We can just put it there just to be safe. Just put it there. So these are the things that you need to remember. There's 4 lines and there's 2 things, and this extend C to turn off name mangling. And then that's pretty much all you have to do inside your header file. And then CPP grid, let's see. Name will be mangled during DLL. Compilation, since C++ classes can only be used in C++, it wouldn't make sense to export this as extend C. Okay, so don't have to worry about all of this. Only thing you have to worry about is what's inside extend C. That's what you're exporting, right? So I think this should be fine, like this. That's your header file. You're done with your header file, and then now to the main. Let's check how the main should be implemented. You just import the DLL, and then let me see what. Why are they saying underscore? Yeah, I don't understand why when they're importing it, they're saying underscore DLL, because it just, or maybe that's how they named it. Oh yeah, I see. That's how they named it. They said example underscore DLL. Okay, so as we named it just DLL. So include, I'm just gonna say hash include DLL.h like this. Let's include the DLL, and then we just implement the function. So we have to use the standard call there like this. Okay, remember that other functions were just C++ functions. We don't have to worry about those. You could do this way of not putting the standard call, or you can put the standard call like this. Either way is fine. But they didn't specify whether it should be a Win32 or whatnot. They didn't go into the details. I feel like you're not going to lose marks if you didn't put the standard call here, because they're saying this is a standard call for Win32 API. So if you're calling it on a Windows 32-bit, that's where you have to use that standard call. But here they didn't specify whether it's a Win32 or whatnot. They didn't specify. So to be honest, I feel like this is not needed. We can just leave it out there. And then you just implement your function as what? As a usual function. So it's called what? It's a double, and then copy this, paste it, and implement. So how are we supposed to implement it? What are we supposed to do? Calculate water usage. Int month. That displays the value returned by the DLL's function. when the month is, or when the month is 12 as a parameter. Oh, okay, I see. I forgot to do something here. Okay, we didn't have to implement it. Remember, I forgot something here. We're supposed to implement it here. Example div, CVP grid, mangled during blah, blah, blah. This function was not implemented. That's my main concern. They only implemented it here inside CPP. Or maybe we should, okay, I think we should create its own header file or whatever, its own CPP file, implementation file. Then we implement this function. So dll.cpp. The slides are so vague, man. I don't know why they're like that. They're just so vague. So dll.cpp. We're just gonna assume this is how they want it to be because the slides are just vague. We don't know what's what. What do they want? So I'm just gonna say hash include DLL h include the header file. Then I write the implementation. Let me see if they did. Okay, they didn't put that DLM. Okay, so you don't have to put it. You can just implement it. So we're just gonna assume it has some implementation. So basically, okay, I understand why it didn't matter because they don't care about its implementation. They just want to see the header file and how you would call it inside your main. That's all they wanted to see. The rest, they really didn't care. Okay, view perspectives default. Let's build it again. Undefined. Compiler. Okay, there's compiler issues. Yeah. Yeah, for some weird reason, my code blocks doesn't work as I expect it to work. So yeah, the setup wasn't proper, I'm assuming. Okay, so let me do this. Let me create some project. Let me go inside download. Then make a directory called DLL. And then move inside that DLL. Then another directory called source. Okay, there we go. Then now I'm gonna open that source. Open folder DLL answer. There we go. And then I'm gonna have a main that's CPP. Then I'm also gonna create another file dll.h header file. All the necessary. Oh, okay, I see now. But I forgot this. Yeah, I forgot to put the end if there. DLL import. Okay, let's go back to code blocks. I realized my error where my error was. View perspectives minimal. I forgot to just say NF here. I don't forget that. And if then define underscore declare the declare spec DLL import. Everything should be fine. Yeah, everything is indeed fine. DLL import. Yeah, everything is fine. Just that I think the way I set it up, it wasn't it's not set up properly, my IDE. Yeah, I don't know why it's doing that, because it should be working perfectly fine. Oh, okay, I see my problem. So you define without the underscore h, yeah, without the header. Yeah, you're supposed to just do this. So without the underscore. Yeah, now I see the problem. So you're supposed to define without the underscore h. It's basically just the name of the header file. Like this. And let's do it again. Okay, I don't know why it's doing that, but that's all you had to write for the code. So you only have to write all of this. I just forgot the end if there. Let me check something here, because I don't get. Okay, I don't get why it's highlighting on this one, but then it's not highlighting here. It could be because of my compiler, how my code blocks is not set up properly. I just also double check. Yeah, I also made a mistake there. There shouldn't be an underscore h here. But my code blocks, I don't think it's gonna work because of that, the compiler and whatnot. Yeah, so just declare it like this. Just declare it like this. Yeah, it should work. Just that on my thingy, on my code blocks, it's not set up properly. You see, I can't see C++ 11, 17 here, or 14, or even 11. I'm only seeing 98. The one released in 1998, which is a very old one. So yeah, it should work perfectly fine. And then now they want to see how you'd call the main. Okay, we're gonna check the batch file. I'm gonna write the code for that now, but before we do that, let's write code for the main. So write code for the main.cpp file that displays the returned value by the DLL's function when the month is 12, provided as a parameter, which is something basically simple. It's I just want you to say cout, and then what is it? Distance. What is it called? What is this function again? Calculate water usage. So calculate water usage, and then you pass 12 as the month. That's what they wanted to see. You outputting it like this. This is what they wanted to see. Because if you check the slides, I don't know if whether they wanted you to use the standard call. I don't know if that was important, what, but they just said you calling the function. That means you may assume the implementation is already there. This is how the main would look. This is how you'd call the power function, you see. Just cout, and that's it. That's all you have to write. Cout that returned value of the function. Done. You don't have to write in a lot of things, and then you include the header file. That's it. You're done. And then, so we are done with that question, because I just want you to call it in main to just output the return value, which is just this. That's all they want to see. So yeah, and the header file, there's going to be marks for including the header file. Okay, let's just close this. And then the last question